the next thing I'm asking you to do is a flex budget performance report. And for a flex budget performance report, we're going to figure out why our actual results are so much different than that in our static or master budget by breaking it down into different types of variances: the sales volume variance and the flex budget variance and the static budget variance. And then we can also break the flex budget variance down into cost and efficiency variances, which we'll do in a little bit here. But let's start by filling out this flex budget performance report. For your flex budget column, the first thing that you need to do is make your number of units equal to your actual results. So if we hit enter and bring this over, we come up with 106,000. The sales revenue in our flex budget is going to be equal to that amount of units that we brought over times the input for that unit. We're selling each one of these headphone cases for $2.50. So if we go through, we enter, it means they're going to generate $265,000 in revenue. They should have generated $265,000 in revenue. For direct materials, we take that $106,000, we multiply it by that unit input, which is 32 cents worth of direct materials. We should have spent $33,920 in materials to make these 350 cases, or sorry, 106,000 cases. We have to go up here, take the 106,000, we multiply that by our direct labor cost of 16 cents. We should have spent $16,960 in direct labor. For variable overhead, we take that 106,000, we multiply it by our variable overhead per unit, 23,320. And for supplies, it says it is 2% of sales. So what we're going to do is we're going to hit equals. We're going to go click on our sales revenue and we're going to multiply it by 0.02. We should have used $5,300 worth of supplies. Our total variable cost in this case is equal to the sum of our different types of variable costs, which are all of these columns. So we go through, we hit enter. We spent $79,000. We should have spent $79,500 in variable costs, leaving us with a contribution margin equal to our sales revenue minus our variable costs of $185,500. Now we can scroll on down to our fixed costs, and nothing gets easier than this. Because fixed costs should not change based on the level of production you had, there's no reason to change them in your flex budget column from what they were in your static budget column, because they should not change even though we made 10,000 more headsets than we thought we were going to. Selling and admin, same thing. So we can just bring those numbers right over from the static budget. Our total fixed cost, therefore, is going to be the same thing, $30,720. To figure out our operating income, we take our contribution margin and subtract from it our total fixed costs. We should have had operating income of $154,780. And with all that information, we can now fill in our different columns. Let's actually go to the bottom first. Our static budget variance. Our static budget variance is equal to our actual operating income minus what we budgeted for. And that comes out to be $21,501. We thought we were going to have $137,280. We actually have $158,781. So that is a favorable variance. If you want to, you can go and type in 21501F. I'm just going to make it easier here. I'm going to mark all favorable variances as green and all unfavorable variances as red. Okay, so we have our static budget variance. We can go over to our sales volume variance. To figure that out, we hit equals our amount in our flex budget minus the amount that we had in our static budget. We were proposing that we had $240,000 worth of revenue. Because we sold more units, we should have had $265,000 worth of revenue. More revenue is good for the company, so that's favorable. Let's make it green. For direct materials, we should have spent $33,920. We proposed we were going to spend $30,720, which means we got a difference of $3,200. That number means we are spending more than we planned on for direct materials. Always going to be the case when your flex budget units is higher than your static budget units. We can go right down the line and fill in each thing this way. Direct labor was $1,600 more than we planned for in our static budget. That is unfavorable. It's a higher cost. Variable overhead is $2,200 more than it was in the static budget, also unfavorable. And supplies. Oh, clicking the wrong one first. Don't do that, folks. Flex budget minus static budget is $500 more than we thought it was going to be. So we can fill that in red as well. For our total variable costs, in total, our static budget, what we should have spent, is $7,500 higher than what we proposed we were going to spend. But our contribution margin was $185,500, and our static budget of $168,000 means we had a contribution margin difference of $17,500. Contribution margin is good for your company. You want contribution margin as high as possible, so that variance is favorable. Let's make it green. For manufacturing, guess what this is going to be? 0, 0, 0, and it's always going to be true on here. All of your fixed costs are always going to be 0 in sales volume variance because fixed costs do not change when sales volume changes. For operating income, you take your flex budget amount, subtract out your static budget amount, and it comes out to $17,500. More operating income is good for the company. We can make that green. And with that, we are through the sales volume variance section of this. We can go over to the flex budget section. Our actual results were $260,000 minus our flex budget amount of $265,000. We should have made $265,000 in sales revenue. We actually only made $260,000, which that means it's less than we thought it was going to be. So let's go and make that red because that's no good. For direct materials, we actually spent $43,890. We should have spent $33,920. Means we have a difference of $9,970. We spent more on materials than we thought we were going to. That is definitely not good. For direct labor, we actually spent $13,122. Our flex budget says we should have spent $16,960 based on the direct labor amount per unit, which means we have a difference of $38.38. We spent less in our actual results than our flex budget says we should have, and spending less on labor is good for your company because it increases your profitability. Variable overhead, same thing. Our actual results minus our flex budget amount shows us that we had a $14,313 variance, flex budget variance, in variable overhead. And since it's so much less, it is favorable. So let's make that green. Supplies. We actually spent $5,200. Our flex budget says we should have spent $5,300, which means we spent $100 less than we should have. So that becomes favorable. We're going to make that green. For our total variable costs, $71,219 minus our flex budget amount of $79,500. I don't know what just happened there. I put a slash in afterwards. Let me get that out of there. There we go. There's a difference of $8,281. Our variable costs are far less than our flex budget says we should have paid, so we can make that green. Our contribution margin of $188,781 is greater than the $185,500 we should have spent, so that's favorable. Let's make that green. For manufacturing fixed costs, we actually spent $20,000. Our flex budget states we should have spent $20,020, which means that is $20 less than we had planned on. 20 bucks is 20 bucks. That is favorable. Our selling and administrative expense was actually $10,000. Flex budget says it should have been $10,700. We spent less in costs than our flex budget said we should have, so that is favorable. And our total fixed costs, obviously, if you're catching on the trend here, has to be favorable. It is favorable by $720. In total, we go to our operating income, We had operating income of $158,781. Our flex budget says we should have made a little under $155,000, which means we had $4,001 variance in operating income, and since it's higher, it is favorable. What does this all mean? Well, we can look at our variances and figure things out. Whenever your quantity produced goes up, your cost of production, your materials, your labor, your overhead is always going to go up. So we can attribute some of the difference between our static budget amount and our flex budget amount purely to the fact that we made more headsets than we thought we were going to. However, we did have positive sales volume variance. That overall static budget variance of 21,501, 17,500 of that can be explained by the fact that we sold more cases. For our flex budget variance, we can go through and look at the numbers and see that our sales revenue is lower than our flex budget revenue, which means we didn't get the full $250 we were expecting per headset. For direct materials, we spent almost $10,000 more than we should have according to our flex budget. And so something is off there, and we have to figure out why that number is so far off. Same thing with labor. We spent way less in labor than we were planning on according to our flex budget, and we really spent less in variable overhead than we were planning on according to our flex budget. So all of these differences here, we have to know why. Why is our actual results so far from our flex budget? And the only way that you can figure out the flex budget variance is to break it down into its two components, which are your cost variance and your efficiency variance, which conveniently brings us over to our variance analysis. So we have Headset over here, who is manufacturing these headphone cases, and they're going to use direct labor hours as their cost driver for both VOH and FOH. The company budgeted to spend $30,720, same thing we had last time, in fixed costs. And again, they budgeted to produce $96,000. They actually produced $106,000. We have their actual information in here. These are their standard costs, what the company plans on spending per each input. So for direct materials, it takes 2 parts, and the cost is 16 cents a part. Direct labor, it takes about 0.02 hours to make a headphone case, and the cost that they pay for labor is $8 an hour. Because they use direct labor hours as their cost driver, VOH and FOH are going to have a quantity equal to the cost driver quantity, so 0.02. They're allocating at $11 per direct labor hour for VOH and $16 per direct labor hour for FOH. We have our actual information down here, which is the actual pounds of material used of 209,000 pounds. The actual cost of direct materials was 43,890. The actual amount of direct labor hours is 1,620. The actual cost of direct labor was $13,122. The actual VOH was $9,000, and the actual FOH was $30,000. The first thing we can figure out is our direct materials cost variance. So to figure out our actual cost per part, we are going to take the cost of direct materials and divide it by the number of parts that we used, which was 209,000. Comes out to 21 cents. We actually spent 21 cents per part to make these headphone cases. Our standard cost is given in the information at 16 cents. And the actual quantity of materials that we used was 209,000 parts. So to figure out our direct materials basis, cost variance, what you're going to do is you're going to find the difference between actual cost and standard cost, and you need to put these in parentheses first because of order of operations. And we're going to multiply that by the actual quantity that we had. So your formula should be equals cell B23 minus C23 in parentheses times D23, and that's going to come out to be, when we convert this to money, $10,450 direct material cost variance. So we can go back to our information to figure out our direct material efficiency variance. The actual quantity of materials that we used was 209,000. Our standard quantity should be equal to the amount of materials we plan to use per unit that we produced, which is 2, times the number of units we actually produced. How many actual cases did they make? They made 106,000, the number that we used for our flex budget before. Which means our standard quantity, if we use the same amount of parts that we did in, our standard costs that were set by the people in the company, we should have used 212,000 parts. And the standard cost, we can just fill in from above. The standard cost for materials is still this 16 cents. So let's fill that in. And the formula for your direct materials efficiency variance is your actual quantity minus your standard quantity in parentheses times your standard cost. And let's convert this to dollars. Comes out to be $480. So, up here, direct materials cost variance. We planned on spending 16 cents per part. We actually spent 21 cents per part. That is not good for our company that we're spending that much more on materials than we planned on. So that is an unfavorable variance. We used 209,000 parts. Our standards say we should have used 212,000, which means we save money by using less parts. And since we save money, that is going to be a favorable variance. If we go back to our Flex Budget Performance Report, we see that the overall variance for direct materials was 9,970 unfavorable. If you go over here, if you took 10,450 and added to it or subtracted from it that $480, you would come up with 9,970. So that flex budget variance is composed of these two things. When someone asks why are we so far off with our materials, we can go and break it down to these numbers and we'd be like, we were pretty efficient with the parts that we needed, but we just paid a ton more for each part. So the cost is the problem. We have to go and look and see if we can find cheaper vendors to get these parts cheaper. We can move on to our direct labor cost variance. And for direct labor, we got to figure out our actual cost. We're going to do that by taking the actual cost of direct labor, which is 13,122, dividing it by the actual amount of direct labor that we needed, which is 1,620 hours. We come up with a cost of $8.10. We spent $8.10 per hour paying our employees. This is higher than the standard cost that we have up here of $8. And the actual, I don't know why I have so many decimals over here. There we go. And the actual quantity that we used of direct labor was at 1,620 hours. So if we go over here to our direct labor cost variance, set the formula up the same way we have, actual minus standard in parentheses times our actual quantity, we get 162. Convert that to a dollar sign. We spent $8.10 per hour on labor. We planned to spend $8 per hour, so we spent more on labor than we thought we were going to, which means that this number has to be unfavorable. For efficiency variance, we're going to go down to our actual quantity of labor used, and our actual quantity of labor used was 1,620, and we fill that in. For standard quantity, we're going to find it out by taking how many hours we planned for it to take to make each unit, and we're going to multiply it by the number of units we actually made. One more time, if we go back to our information, we actually made 106,000 cases, so let's multiply that out times 106,000. It means that we had a standard quantity of 2,120. We should have taken 2,120 hours to make these cases. We actually took 1,620 hours to make these cases. Well, our standard cost for labor, we can take from our information above, was $8. And we can fill out our formula much in the same manner. We equals, open our parenthesis, actual quantity minus standard quantity, close our parenthesis and multiply it by standard cost. We come up with negative 4,000, which I'm going to change to dollars. We thought, according to our standards and the amount that we produced, we should have had 2,120 hours worth of labor required to make these. We actually only took 1,620 hours to make these. Well, when it takes you less time to make your product, you pay less money in wages, so that's good for the company. So again, we had a very favorable direct labor variance over here. As you see, $3,838. What's the reason for it? Well, we spent a little more in labor than we thought we were going to, but we got it done in way less hours than we expected. Moving on to our variable overhead cost variance. We need to figure out our actual costs, and our actual cost of variable overhead was, per unit, was the actual VOH of 9,000 divided by the number of units that we actually made. No. Next up, we have our VOH cost variance. To figure out our actual cost per unit of the cost driver, we take our actual VOH and divide it by the amount of the cost driver that we had, which was 1,620 hours, and it comes up with $5.56. Well, our standard cost, listed up above, is supposed to be $11 per hour, and the actual quantity of our cost driver was the 1,620 hours. So we planned on allocating $11 per direct labor hour. When we got our actual variable overhead costs, to get to that number, we should have only allocated $5.56 per hour. So we can figure out our cost variance by taking our actual cost minus our standard cost and multiplying it by our actual quantity. And it comes out to negative $8,820. So if we go up here, we change that to money, and we're good. Again, our cost is way less than our standard cost. As you can see over here, from variable overhead, we had a very favorable variance. The reason being, our costs just weren't anywhere near what we thought they were going to be, so that's favorable. For our VOH efficiency variance, we're going to take the actual quantity of direct labor, our cost driver, that we used. We need to fill in our standard quantity, which we already figured above. Our direct labor standard quantity was this 2,120. And we're going to need to fill in our standard cost. This is for our variable overhead. If we scroll up, we see that the standard cost for variable overhead was that $11. We're going to click on that cell and we're going to hit enter. To figure out our VOH efficiency variance, we're going to hit equals, and we are going to multiply or find the difference between actual quantity and standard quantity and multiply it by our standard cost. We come up with negative 5,500. So we used way less of our driver than we thought we were going to, and that in this case is going to be favorable for us. So we have two hugely favorable VOH variances, and when we go over here, we see that our variable overhead variance was 14,313, very favorable, which is conveniently pretty close to the sum of these two numbers. You might ask why it's a little bit off, and it's because Excel doesn't round this to the nearest penny. I'm fine with that. You can just leave it that way. So, variable overhead cost variance. Easy enough. What is our actual fixed overhead? Well, our actual fixed overhead given in our information was over here, 30,000. So we can go back to our variance analysis, and we need to click on this and bring that 30,000 over. Our budgeted fixed overhead, coming back to this thing, was 30,720. All your fixed overhead cost variances is the difference between those two numbers. 720. We spent less on fixed overhead than we had planned for. So, what does that mean? That means that's good for the company. Forgot to change this guy to $sign too. Let's do that. For your fixed overhead volume variance, what you're going to do is you're going to take your budgeted fixed overhead, which we can find over here. We budgeted to have total fixed costs of that 30,720, and we need to figure out how much we allocated. What we are planning on here was allocating at a rate of $16 per hour. And if we multiply that by the standard quantity of our cost driver of 2,120, we come up with 33,920. Find the difference between those two numbers, and it comes out to 3,200. Change that to a dollar sign. We had budgeted fixed overhead of 30,720. We allocated fixed overhead of 33,920. And people look at that and they say that's got to be unfavorable because we allocated more than we budgeted for. But why did we allocate more than we budgeted for? It's because Headset was planning on selling 96,000 cases and they actually sold 106,000. So when your sales go up, you're going to make more product, which means you're going to allocate more overhead based on your standard cost. So in actuality, having over allocation of overhead is good as opposed to under allocation. So we're going to call this a favorable variance. And with that, I'm through the whole kit and caboodle, so good luck on your test, folks.